Okay, today we are going to solve some problems from organic chemistry from the hydrocarbons chapter. The first question here is, let me read the question first. The product obtained via oxymercuration means we need to react with IgSO4 and H2SO4 of but 1 ion would be, means when we perform oxymercuration with but 1 ion, what will be the measure product? This is the question. Okay, let us understand what is oxymercuration, demercuration. It is nothing but in an unsymmetrical alkene. This is an unsymmetrical alkene actually. When it is reacted with some Ig2 plus, then we will need to add water only according to Markovnikov's rule. So CH3CH, here OH will come from water, and CH2 hydrogen will be obtained like this. We need to add water according to Markovnikov's rule. Okay, so in this case our reactant is but 1 ion. So this is the compound, and we need to add water. IgSO4 and H2SO4 means in the reaction we need to add water only. So 2 moles of water will be added here because 2 pi bonds are here. So 2 moles of water, when it is added according to Markovnikov's rule, we will get CH3CH2C. Here OH will come, another OH will come here, and the 2 hydrogen atoms will be attached to this carbon atom, so we'll get CH3. So this is a geminal diol which is not stable, so one water molecule will go out to form a carbonyl compound. So the product will be this one. B will be our major product. Water will remove, and we will get a carbonyl CO. Okay, this is the answer. The second one is the answer. Let us go to the second question. Let me read it. Propine and propene can be distinguished by, this is propine. Propine is CH3CH. No, this is propine, and the propene is CH3CH double bond CH2. This is propine and this is propene. So these two compounds can be distinguished by which reagent? Now in this case we need to check, because this reagent reacts with an acidic hydrogen. So in propene there is no acidic hydrogen, but in propine one acidic hydrogen is attached here. Therefore this propine will react with AgNO3 Ag plus, while propene will not react with this compound. And the other reagents, this H2SO4 and bromine in CCl4 and dilute KMnO4, they all will react with these two compounds. In this case hydrogen and HSO4 will be attached, and in this case 2 bromine atoms will be attached, and since there are 2 pi bonds, we will need to add 2 moles of bromine. So these three reagents will react with both propine and propene, but AgNO3 will only react with propine but not with propene. Therefore these two compounds can be distinguished by AgNO3. Okay, let us go to the third question. The third question is, we are given a propine, then Ag2 plus and H plus means acid. A is formed. What is A? So let me write this reaction. pH is here, then C triple bond C, CH3, and when H plus is added like this, we will get a carbocation. pH C double bond C will get, and CH3. Now when H plus is added to this carbon atom, then this carbon atom will carry a positive charge, while when hydrogen plus is added to this carbon atom will carry a positive charge. But which carbocation will be more stable, that will be dependent on resonance. Since this is a phenyl group, pH is a phenyl group, so resonance can be taken place in this site. So carrying positive charge in this carbon atom will be more stable. Therefore this carbon will have a positive charge and one hydrogen atom will be attached here. Now water will attack as the nucleophile here. OH will attach as the nucleophile, pH C. Let me write the compound how. We will get an enol here. Water will attack as nucleophile, okay. Now in this case we will get an enol. So this is not the final product actually, this is the product given in C, but this is not the final product. Since this is enol, tautomerism will take place. Tautomerism will take place and hydrogen will be shifted from here to here and double bond will be shifted like this. So we will get pH C double bond O, and this will be a the single bond CH2, and this is our CH3. So this will be our final product after tautomerism. Therefore our answer will be A. A will be the answer. Okay. Next question is question number 4. Which one of the following will react fastest with H2 under catalytic hydrogenation condition? This is the question. So we are given 4 alkenes. Now we need to check which one will react fastest. Now if we see hydrogenation, rate of hydrogenation, okay, rate of hydrogenation will be directly proportional, inversely proportional to steric hindrance actually. Steric hindrance means bulky group. Now in these two cases only 2 alkyl groups are attached, while in these 2 cases more alkyl groups are attached. Here 4 alkyl groups, 3 alkyl groups, and in the last option where 4 alkyl groups are attached. So this will be least reactive. So the answer will be among this A and B, but we need to check this is cis alkene because the alkyl groups are on the same side, while this is a trans alkene. This is cis alkene and a trans alkene. So which one will be more stable? Since trans alkene is more stable than cis alkene will be more reactive than the trans alkene. And among between these two there are only 3 alkyl groups, but in this case 4 alkyl groups are attached, therefore this will be more reactive. So the rate of hydrogenation will be A will be most reactive, then B, then C, then D. So our answer will be A, the cis alkene will be most reactive. Okay, let us go to the 5th question. Okay, the 5th question is here. The addition of propene, this is propene, with HOCl proceeds via the addition of H plus in the first step, Cl plus in the first step, OH minus ion in the first step, and the last option is Cl plus and the OH minus ion in a single step. So this is not correct because the addition takes place stepwise, but we need to check whether H plus is added first or Cl plus or OH minus ion. Okay, CH3 CH propene, the reactant is propene, this is propene. Now when it is reacted with HOCl, HOCl undergoes self ionization first actually. So CH3 CH single bond CH2, since there is a double bond, it has excess of electron, therefore an electrophile will attack first. So what is the important point here is that this HOCl undergoes self ionization, HOCl, to form H2O and OCl minus and Cl plus, like this. So among these 4 species, the positive part which can act as electrophile is Cl plus. So the first step is the addition of Cl plus. So Cl plus will be added so that we get a stable carbocation as the intermediate. So Cl plus will be attached to this carbon atom so that we get a more stable secondary carbocation. Cl will be attached here. This will carry positive charge. So this will be the intermediate in the reaction mechanism. So after this step, actually water will act as nucleophile to attack this carbon atom, and this OCl minus will abstract one hydrogen from this water part, and to then we will get as the final product this compound. This will be Cl. I am writing in the below part, and OH will be attached here. So HO and Cl will be added, but the first step involves the addition of Cl plus as the in the first step. Okay. So the answer is B. Okay. Then let us go to the sixth question. On monochlorination of 2-methyl butane, the total number of chiral compounds formed is 2, 4, 6 and 8. Now let us draw 2-methyl butane first. This is our 2-methyl, one hydrogen will be attached here. This will be our 2-methyl butane. Okay, monochlorination will take place. Now this carbon atom and these carbon atoms, they will be they are similar. So when one hydrogen is substituted by chlorine, in this case this carbon will not be a chiral carbon atom. So let us write here one chlorine will be coming in this carbon atom, either this carbon or this carbon, they are same. Okay, CH here, CH3 and CH2 CH3. Now let us check whether there is any chiral center here. Is it chiral or not? Since these two hydrogen atoms are similar, this carbon is not chiral, but this carbon is chiral, because in this carbon atom the 4 groups attached are all different. This is a group, this is the second group, this is the third group, and this is the hydrogen is the fourth group. This carbon atom is chiral. So since this is chiral, this compound is chiral compound. So since it is chiral, it can have its RS configuration or D or L. So therefore we get 2 chiral compounds here. And another possibility is when this hydrogen is abstracted or substituted by chlorine, this carbon will not be chiral, because 2 similar groups will be attached here. When it is substituted in this carbon atom, then what will happen? Okay, this may be chiral. Okay, this and this. Now we get 2. Okay, let me write here CH3 CH3 CH. One hydrogen will be substituted by chlorine. Now let us check chirality in this compound. This carbon is not chiral because 2 methyl groups are attached, but this carbon is chiral because the 4 groups attached to this carbon atom are all different: chlorine, methyl, isopropyl group and hydrogen. So this carbon atom is chiral, so it will have its DL forms. Now what will happen if hydrogen is substituted from this carbon atom? One hydrogen will be substituted by chlorine. No, this will not be a chiral molecule, because let me write here like this. Cl, this carbon atom is not chiral, this is not chiral, this is not chiral, this is not, no, this is not possible. Okay, so we have only 4 chiral molecules or compounds. Okay, so answer will be 4, means B. Okay, now let us come to the 7th question. Identify the major product P in the reaction. Now what is this? NOCl, nitrosyl chloride, P. So when nitrosyl chloride is ionized, we will get NO plus and a Cl minus, and this addition will take place according to Markovnikov's rule. So Cl minus will be added to Cl minus, this is minus, this will be plus, Cl minus will be added to this carbon atom, and the NO will be added to this carbon atom. So we will get this as the measure product. B is the answer. Okay, let us go to the 8th question. In the following reaction, the measure product is O. The question part is missing here. Let me check the question here. This is from some app. Actually, I have written this question from some app, but let me write the question. CH2 double bond CH3 double bond, this is CH2. Okay, this is added one equivalent of HBr, one equivalent of HBr. When this alkene is reacted with one equivalent of HBr, what will be the measure product? This is the question. Okay, now let us solve this question. When there are two double bonds, when the alkene contains two double bonds and 1 mole of or 1 equivalent of HBr is added, remember the addition will take place. There are two modes of addition, 1,2 addition and the 1,4 addition, and in this case 1,4 addition takes place actually. This is very important. So 1,4 addition means one of these two will be added to this carbon atom and another one will be added to this carbon atom. When this is numbered as 1, 2, that will be 1, 2 addition, and when one is added to this carbon atom and another atom is added to this carbon atom, then that will be called 1,4 addition. So in this case, remember 1,4 addition will take place. One of the double bonds will be shifted to the center carbon atom. Okay, let me do the reaction here. This is our CH2 double bond CH3, this is double bond, this is our CH2. When H plus is added, H plus will be added first because this is alkene which has excess of electrons, therefore the electrophile will be added first. So when this hydrogen is attached to this, H plus is added to this carbon atom, this will carry a positive charge, but when H plus is added to this carbon atom, this carbon will carry a positive charge. So that is a more stable intermediate. So I am adding hydrogen plus to this carbon atom. So this will become CH3, and this will be our intermediate. This is a positive, and double bond is here, CH2. So there will be a resonance, shifting of the pi bond. So we will get this CH3 C, CH3 double bond will be here, and the CH2 plus, oh no, and double bond will be shifted here. This is CH, and we will have CH2 plus here. Okay, now in this intermediate Br minus will be added, so we will get CH3 C, CH3 double bond CH, and CH2 will have this bromine. So this will be our final product. Let us choose this from the options. I think D is the answer. Okay, let me give one assignment for you guys. Please do this question. I have written already. Please note this question and write the answer in the comment box. This is the assignment part. The question is, among P, Q, R and S, okay, the aromatic compound or compounds is or are. This is a question which can have more than one answer. Okay, so first one is, this is single bond, not double bond. Okay, this is single bond, this is double bond. When it is reacted with AlCl3, P will be formed. That will be intermediate. Okay, that intermediate P, and here one intermediate will be formed as Q. Here R will be formed. Here ICl, when it is reacted with ICl, S will be formed. Among these four compounds, among P, Q, R and S, the aromatic compounds is or are. This is the question. So we need to choose from these options A, B, C, D, and it can have more than one answer. More than one answer. Please make sure you do this question properly. Okay, for today I am finishing the video here. Thank you. Please like this video, share to your friends, and if you are new in this channel, please subscribe this channel. Thank you.